Hello, boys and girls. I wish you could be with me at Duke University today, but you're not. Let's take a look at today's class assignment. On the front side, you have some one-step and two-step equations, and then on the flip side, you have some word problems, which are also one-step and two-step equations. They should be pretty simple. You should be getting more familiar with this. Let's take a look at those problems now. Well, boys and girls, first of all, I just want to say if you want more of a teaching video, you really want to look at the video that I made last night for last night's homework. You might want to review that if you don't understand the processes of isolating the equation. I'm going to zip through most of these problems pretty quick just for you to check for accuracy. Let's take a look at numbers 1 and 2. Here I see number 1, I've got p over 10 is equal to -7. We want to isolate the variable, and this we can clearly see that this is a one-step equation. There's really only one operation being performed on p, and that's it's being divided by 10. We know that every fraction is really a division problem. How do I undo, or what's the inverse of dividing something by 10? It's multiplying it by 10. That's how I can get rid of the 10. And what I do to one side, I need to do the other side as well. That will cancel out our 10 so that I am left with just p all by itself or in isolation. And then on the right hand side, I have -7 times 10, which is a -70. So p is equal to a -70. Over here, I have 18 plus m is equal to 12. I want to get m all by itself. The only thing that's interfering is this 18. 18 is being added to it. What's the inverse of adding 18? Subtracting 18. And what I do to one side, I need to do to the other. When I do this, that gets rid of the 18s. I have the m isolated all by itself. And then a positive 12 and a -18, when I combine these two, I'm left with a -6. So m is equal to a -6. The next two problems that we'll look at for the classroom assignment will be numbers 3 and number 5. Number 3, I have a -17a times, a -17 times a, or a, is equal to 306. Slow down, Bob. What's happening to the a? Before we can do the inverse operation, we have to know what operation is being performed on it. It's being multiplied by a -17. What's the inverse or opposite of that? Divide by 17. And what I do to one side, I have to do to the other. My -17s cancel out. I'm left with a positive a is equal to, 306 divided by a -17 is going to be a negative, 17 will go into 30 one time, which will leave me with a remainder of 13. I bring down my 6, and I'm going to guess that 17 goes into 36. I'm going to say 8 times, because 8 times 7 is 56, carry the 5. 8 times 1 is 8 plus 5 is 13, and we're done. So a is equal to a -18. Number 5, I have my equation is a -19 is equal to m minus 2. I want to get m all by itself. 2's being taken away. What's the inverse of taking 2 away? Adding 2. And what I do to one side, I'll do to the other. My 2's cancel out. I bring down my m. M is going to be equal to a -19 plus 2, which is a -17. And some of your teachers are going to be real sticklers about this. They want you to switch it around, always have the variable on the left-hand side. -17 being equal to m is the same thing as m being equal to -17. The next two problems, we have our 14 and 15 that we'll look at. When I look at 14, I have 4 times the difference of x and 4 is equal to a -20. Well, the first thing we always have to do when solving equations, if we see that there's any like terms that we can combine or any distributing, we need to do it because we need to simplify the equation before we solve the equation. And in order to simplify this equation, we need to distribute first. And when I distribute the 4 times each of the terms inside the parentheses, I get 4 times x, which is 4x. And then 4 times 4 is going to be 16. And that'll all be equal to 20. Now I have an equation that I can solve. I first have to ask myself, is anything being added or subtracted? And yes, there is. There's a 16 being taken away from our variable. So I need to do the inverse of that, which is add 16. And what I do to one side, of the equation I must do to the other to keep it balanced. Okay, my 16s cancel out. I bring down my 4x, and 4x is equal to a negative 20 plus a positive 16, which will be a negative 4. Now the only thing being done to the x, the only operation, is being multiplied by 4. The inverse of that is divide by 4. I do that to both sides, and I get x is equal to a negative 1. Over here, I've got no simplification to do. I just can dive right into this. The first thing I need to ask myself is anything being added or subtracted to the variable side, and the answer is yes. 1 is being taken away. The inverse of taking 1 away is adding 1. And what I do to one side, I need to do to the other. Okay, that cancels that out. I bring down my n divided by 2 is equal to a negative 4 plus 1. And a negative 4 plus 1 is going to be a negative 3. And so now I have n divided by 2 is equal to negative 3. Well, what's happening to n? It's being divided by 2. If I wanted to isolate n, that's always the goal, to get the variable all by itself. I need to perform the inverse operation, which the inverse of divide by 2, you guessed it, is multiply by 2. And what I do to one side of the equation, I must do to the other to keep it balanced. My 2's cancel out. I'm left with n on the left side, and on the right side I have a negative 3 times 2, which is a negative 6. Another one down. Let's look at two more problems. Number 16, I have a negative 3p plus 2 is equal to a negative 25. Okay, there's nothing to simplify, so I need to dive right into solving the equation. I want to isolate the variable. Is anything being added or subtracted first? And the answer is yes, 2 is being added. What is the inverse of adding 2? Subtracting 2. And what I do to one side, I must do to the other. That cancels out the 2. I bring down my negative 3p, which is equal to 25 negatives and 2 more negatives would give me a total of 27 negatives. Then I ask myself, what's happening to the variable p? It's being multiplied by negative 3. What's the inverse of being multiplied by negative 3? Being divided by negative 3. And what I do to one side of the equation, I must do to the other to keep everything balanced. And negative 3 divided by negative 3 is a positive 1, so I have 1p over here. You don't need to write the coefficient. It's kind of unnecessary, silly. A negative 27 divided by negative 3 is a positive 9. There you have it. Let's take a look at number 20. Now number 20, it's an interesting one. The variable is embedded in the fraction. It's not just, floating around as the numerator of a fraction, but it's actually inside of the fraction. So we can't attack this negative 8. You can't extract it. The only way to do this is the exception. We've got to change this funky looking fraction into just a regular expression. We got to get rid of the fraction form of it. And if this fraction is really negative 8 plus a divided by 9, the inverse of that is multiplying it by 9. So we're going to multiply this whole fraction by 9. That's going to get it out of fraction mode. And what I do to one side of the equation, I must do to the other. So I'm going to also multiply this side by 9. And I'll take care of this first. And 9 times a negative 1 is going to be a negative 9. And over here, my 9's cancel each other out very nicely, and I'm left with a negative 8 plus a. Okay. We're clearing things up. We still don't have the variable all by itself. What's happening to a? A negative 8 is being added to it. What's the opposite of adding a negative 8? Well, adding a positive 8. Let's do that. And what I do to one side, I'll do to the other. Okay, and the negative 8 and positive 8 cancel each other out. I bring my a down. Okay, and I have a negative 9 plus 8 will leave me with a negative 1. So, okay, let's switch around. A is equal to negative 1 for all of you sticklers out there. Finally, let's do our last non-word problem equation. Again, we have, this is similar to the last one we did together. The variable is embedded inside the fraction, so we got to get rid of this fraction form. We need to remove this denominator of 7, and the only way we can do that is by multiplying the whole thing by 7. And what I do to one side, I'll do to the other as well to keep everything balanced. The 7's cancel each other out. I'm left with 9 plus 4 is equal to 3 times 7, which is 21. I need to now get rid of the plus 4. the last operation that is being applied to the variable, which the inverse of plus 4 is minus 4. What I do to one side, I do to the other. The 4's cancel each other out, and I'm finally left with the variable in isolation. N is equal to 21 minus 4, which is 17. N is equal to 17. Let's take a look at some of the word problems here. The first step we want to do is change it to an equation, and this one's going to one-step equation, and then solve for the variable. Okay, so Sam's High School played 14 games this year, so that's the total of how many games they played. That's equal to 14. The team won most of their games. We don't know how many they won. They were defeated during 2 of their games. So wins plus losses, the two wins here, that's their 2 losses. How many games did they win? Okay, so we know the wins plus losses equal total games played. We don't know how many wins yet. They had 2 losses. Here's our equation. Wins plus 2 is equal to 14. I need to subtract 2 from both sides. That cancels each other out. I bring down my W. The football team won 14 minus 2, which is 12 games. Okay, problem number 6. After paying $8 for the pie, Nancy has $86 left. How much money did she have before buying the pie? Okay, so this is the total amount of money that she had, we'll call M. Okay, she spent $8 for the pie, that's minus 8. And after spending $8 for the pie, Nancy had $86 left over. Here's our equation. M minus 8 equals $86. M is the total amount of money she started with. Well, we want to isolate the variable M. What's the opposite of subtracting 8? It's adding 8. We add 8 to both sides, and we're left with M is equal to 86 plus 8, which would be $94. Our 2-step equation word problems, let's see, it says Sally had $85 to spend, so she started out with $85, and to spend on 7 books, so she's buying 7 books. After buying them, she had $15 left over. Okay, sounds like we're doing multiplication and division here. Okay, so there's, she had $85 to start out with, then she bought 7 books. Buying, you're going to spend money, so that's taking money away from the $85. 7 books. We don't know how much each book cost, but we know that when she was left over, after buying the 7 books, she had $15 left over. So here's our equation. Well, the first thing we need to do is we need to get rid of this 85 here, okay? So what's the opposite of having 85? We got to subtract it. What we do to one side, we're going to do to the other. Okay, the 85s cancel each other out. We get negative 7b is equal to 15 minus 85. The difference between 85, this is going to be 70. Actually, a negative 70. Okay, and now I want to isolate the variable b. It's being multiplied by a negative 7. The opposite of being multiplied by a negative 7 is being divided by a negative 7. I'm going to do that on both sides. The negative 7 divided by negative 7 is just b, a positive b. And a negative 70 divided by a negative 7 is a positive 10. So each book must have cost $10. And sure enough, 7 times b is 70. If I take 70 away from 85, that'll give me $15 left over. Okay, this is a good one. I like this. Fred bought 7 new baseball cards to add to his collection. The next day, his dog ate half of his collection, so he increased his collection by 7, and then that total was decreased, was cut in half because the dog ate half of it. There are now 37 cards left. How many cards did Fred start out with? Okay, well, we don't know how many cards he started out with, so we'll call that C. Okay, then he bought 7 new cards. Okay, now he has a new total. And then it says dog ate half of them, so we have to divide that by half. And now there's only 37 cards left. So there we go, okay? C is the number of cards he started out with. He bought 7 more. His dog ate half of them. And we know that he was left with 37, which would be equal to that half that the dog ate, because he ate half and he left half alone. I guess he was full. Anyway, here we've got the variable is embedded in a fraction, so we got to get rid of this fraction form here. Going to switch colors. Got to get rid of this denominator here, and the best way of doing that is by multiplying it by 2. This whole thing is being divided by 2, this whole expression, so we need to multiply the fraction by 2. And what do I do to one side, I do to the other. The 2's cancel each other out. I'm left with c plus 7 is equal to 2 times 37. 2 times 7 is 14. 2 times 30 is 60. So 60 plus 14 is 74. And then I need to isolate the variable c. C is having 7 added to it. The inverse of that is subtracting 7. What I do to one side, I need to do to the other. So I get, these cancel each other out. 74 minus 7 is 67, which is equal to C. So Fred started out with 67 cars. As always, boys and girls, I hope that was helpful. Please bring any questions that you have tomorrow to class. I'll see you then. Bye-bye.